Okay, let's try to go over this data cleaning with pandas again. Okay, like I said earlier, that our learning objective is identifying and handling missing data effectively, try to detect and remove duplicates, handle outliers. Then we try to assess the quality of our data before we talk about cleaning the data and doing data analysis. Okay, but the first conversation then is, what are missing values? Because definitely what you are doing in data cleaning is you are cleaning missing values, either you are replacing them or you are changing them or deleting them. But first, what are missing values? Missing values actually refers to absence of values in our data set where those informations were expected, and those missing values may likely come from or occur from values or observations that were not recorded, and this results in gaps in our data set, and these missing values actually affect our analysis. Remember, in computer we said garbage in, garbage out. So the quality of your data determines the quality of your result or your output. So if you are doing analysis with a wrong data set, with data set that is not very clean, your output is also going to be very wrong. Now, but how do you handle missing data? Look at this emoji here. It says missing values, let's input them quickly. No, this is a wrong approach. The right approach is, I must understand why do I have missing values before imputing them. So domain knowledge is very important. You have to first understand why those missing values we are missing, what happened to those missing values before thinking of the strategy to impute or replace them. But why data cleaning matters in the reality of reward data is that all reward data sets are always unclean, so we have to clean them first. And this is a very funny quote, that data scientists spend 80% of their time cleaning data and 20% of their time complaining about cleaning their data, which almost over 100% of the time cleaning and complaining. And just the moment you, as an analyst, the moment you are able to clean all your data set, you just realize that analyzing it is not even a problem again. Now, but how, what are the common data issues we normally have? Inconsistency. The first one is missing values. We may likely have empty cells that has the values of NEN, NULL. Sometimes we have repeated records and inconsistent formatting. Maybe someone writes 5th July 2026, someone else writing July 15th 2026. Then we also have outliers. Outliers are extreme values, and those extreme values may be wrong or may be correct. Then we also have invalid dates and inconsistent namings. These are the different ways data unclean data sets appears. And the impact of unclean or the impact of dirty data on our analysis is that it gives us an incorrect analysis, and it also makes us make poor decisions, have wasted resources, and also lose opportunities. But how then do we, what are the processes involved in cleaning data? The first process is inspection. We have to first understand our data set. You don't just impute, you don't just replace, you don't just drop the columns. You have to first check what happened to this data set. Why is this data set unclean? Then next thing is you have to look for the problem after you've inspected your data, know the different rows and columns, how many rows the data set have, how many columns, what are the data types. Next thing is now look for the problems in the data. So once you are done, you now check for the appropriate cleaning strategy. It's from understanding your data set that you will now know that this particular error in the data, it needs this kind of strategy, needs this kind of cleaning strategy or not. Then once we are done, we have to validate our results, then document what happened, because this is one of the most important part, documentation. Anytime you are done with your analysis and you did any kind of data cleaning, always document what you changed, the rows you dropped, the columns you dropped. Always document it, because this will look like a reference point when you maybe you are trying to defend your analysis in the future. So these are the 6 processes: first inspection, next detection, decision, implementation, validation, and then you document. We have different types of missing data, and we have missing data by completely at random. This kind of missing data completely at random is not the fault of the person that is imputing those data. Those missing data at random, maybe we are trying to we are conducting an online poll, and there was an internet job which may randomly not collate all the submissions. Those submissions that were not collated are missing completely at random. Then we have the ones that are missing at random. This one was deliberately done by you. Maybe it was in an exam hall, and the particular student did not fill in all the answers. I mean, the particular one, he or she didn't get correct, didn't know the answer, he just skipped that question. That one is called missing at random. Then missing not at random. Then we have another one. The missing not at random is actually directly related to the value of the missing data itself, and it's actually the most challenging to handle because it always introduces biases. Maybe for instance, we are having an analysis and a survey, and in that survey they asked, what are your incomes? Someone actually said my income is 5,000, whereas the person's income is 50,000. So these ones are missing not at random. It's deliberately by the person in filling in this survey. Then what are the various kinds of missing data representations? How are missing data represented? The first way is always represented with NaN, NuLL, N/A. Those are the different ways missing data are represented in analysis. Then how do we identify them? We use the df.isNull to know. Once we use df.isNull, it's actually a method in pandas. It's going to pull out all the null values for us. Then we are going to do the practical, but let's look at how do we deal with it. There are various strategies in data cleaning, and one is we may likely drop those missing values. Either we drop the rows or we drop the entire columns. Another way is we may likely do imputations. Now, if you are doing imputation, maybe you are calculating the mean of that column, or the median of that column, or the mode of that column. Then another way we do it is we do use some imputation algorithms, where we either use simple imputer, interactive imputer, and KNN imputers. But these ones will not go into those kind of data cleaning. Those ones are for data science when you are preparing your models. Alright, so this is just the basic foundation about data cleaning, dirty data, the effect or the impact of those dirty data on our analysis, and what are the processes of data cleaning. Let's now look at a real world scenario. The first thing we are going to do as data analysts is that we are going to import our data. But the first thing we have to do is, let's open this now. Let's import pandas first, because pandas is actually the library that we are using for data cleaning. Remember, we use pandas for data cleaning, data analysis, data visualization, and basic statistical analysis. Then we are going to import pandas as PD. Then we are going to import NumPy. We also need NumPy as MP. Then let me run this line of code. Good, we are good to go. Now what do we do next? We are going to import our data set. Now because we are on Google Colab, this is the process of importing our data set. Now you have to get your data set first. Those data set either comes in CSV files, that comes in Excel files, TXT files. They also come in JSON files. There are various ways that the data set may actually come. So what you do is that you have to upload the data set into your environment. And how do you do that? Let's click on this to expand. Let's click on this to expand it. Then these are runtime to enable runtime files. So let's allow it to load so that we'll be able to import our files. Now you either download the CSV file or the Excel file into your local machine. Then you come to this place to upload that particular file. So let me look for where that file is on my system. Let me go to download. Okay, let me click on it now, download it. Okay, now we have the CSV file here now. So what we are going to do is we are going to copy the path of this CSV file. Click on this three dots here and copy the path. This is it here, copy the path of the CSV file. Now there is a method in Pandas that we use in calling or reading a CSV file into Pandas, and that is called the pd.read_csv. Now it comes up here. If it is an Excel file, it says read_excel. If it's a JSON file, it says read_JSON, but because it's a CSV file, we say read_CSV. Then we now open our bracket. Okay, now the part that you copied, you are going to paste it in the middle. Then you run. Now okay, let me run this code again. Just give me a second. Let me run this again. Okay, let me now run this one again. So it's now working. Alright, so this is now our data set. So we can, because we can actually call in this data set into a variable. So let's name the variable df. df is equal to, so it reads this data set into this variable called df. We are going to call the df here now. So let's run it again, and it's still going to give us the same result. So why we are doing that is, instead of always writing pd.read_csv, we just call this df and it gives us the same result. So what are the first thing we need to do as the data analysts are going to clean data set? Remember the processes. Let me scroll up. The first thing, we are going to inspect and then detect. So let's scroll down. Let's start to inspect our data set. How do we inspect? Now remember, we just call our df now to check the data set. But if the data set were having like 1000 rows, 5 million rows, how do we check the first 5 rows and the last 5 rows of our data set, so I'll be able to understand the scope of the data set itself? So we use what is called the df.head. df.head. Give me a second. Then we open bracket. Now by default it's going to give us the first 5 rows. We can actually tell it to give us the first 10 rows, the first 20 rows, the first 30 rows, or the first 50 rows. So we are just interested in seeing the first 2 rows. So let me just say df.head and 2. So it's going to return the first 2 rows for me. There's another thing we also need to do. Maybe we want to check the last 2 rows. We say df.t, and that also gives us the last 2 rows. So let's run that again. So you now get the last 2 rows. Another thing we also need to consider when we are doing data inspection is we are going to tell Pandas to describe the data set for us. So when Pandas is describing the data set, we can actually tell him to tell us how many columns and how many rows does our data set have. So let's check that now using the df.shape method. So let's call it df.shape, and let's run this code now. Now we are still trying to inspect our data set. It's telling us that this data set has 5 rows and 7 columns. 5 rows and 7 columns. Now there are other ways you can also get this same result in the df.shape. You can always get it like this. If you are only interested in the number of rows, it says df.shape 0. It's going to give you only the result for the rows, and if you say df.shape1, it's going to give you the result for only the columns, right? So df.shape0 is telling us that the data set have 5 rows. So if you say df.shape1, it's going to show us that the data set have 7 columns. So 0 is rows and 1 is columns. So let's still inspect our data set again. Well, let's look at how many columns have let's try to use the df.info to check the entire information of our data set. So this just quickly, let's just say df.info. These are just short codes and they are not difficult to remember. Now using the df.info is going to describe or tell us the information about the data set, and let me explain what is saying here now. Now index are always rows. So when you hear about index, what should come into your mind is rows. It's telling us that our data set have 5 rows and the index are from index 0 to index 4. That's number 0 to number 4. Remember, in programming we write from 0. Then it's telling us that the columns have 7 columns. Then these are the columns. Now the first column is first name, and this first name has 4 values, and those 4 values are non-null, and the data type is an object data type. And the last name has 4 values, and they are non-null, and they are also an object data type. The age as well, the age is a float data type. Sex is an object data type. Pre-test call is an object. Post-test call is an object. Location is an object. But looking at this data set, there's the let's try to inspect our data set now. Remember, pre-test call is a figure, their values. Pre-test call 62, 63. Why is it now an object? Is a concern. So it means we have to change this data type from object to float so that we will be able to do numerical calculations on it. Same with the post-test call. The location has imagine the entire location column has only 1 value. The remaining 4 values are null. So with this now, we've been able to understand or inspect how our data set looks in real life. Now let's look at the last thing. Now we've been able to see that okay, out of the 5 rows, 4 is here. 4 is non-null. Out of the 5 rows, 4 is non-null. But what if you don't want to start doing plus and minus to know the exact number of rows that are missing in each column? How do we do that? We use the df.isNull. Alright, so let me just type that. So you are telling pandas to show me all values or all cells that has no values, right? This is what it means. And now we want it to calculate it for us, to sum it per column for us. So that's why we are adding the dot sum. So this will run, but we are telling it that instead of you typing it either, because now this is going to give us a boolean result. Let me run it for you first so that you see it. It's going to give you a boolean result. You see, false true, false true, false true. No, we don't need this. We want it to calculate it for us, so we just use the dot sum. And let me run it now. See, the first name is telling us it has 1 null value. Last name has 1 null value. The sex has 1 null value. The pre-test and the post-test don't have any null value. Then the location have 4 null values. You see that you are now discovering your data set, now understanding where issues are coming in your data set. The next thing is now we've inspected our data set, we've seen where errors are coming from. Now let's start to do the normal data cleaning processes. The first thing we need to do is we need to remember some of our data sets we are actually in a wrong data type, so we need to convert it to the data type that they were supposed to be in. So let me run this code again to see my data set again. So let me say df.head 1. So let me just say the first column, so I should not occupy a lot of space. Okay, all right, this is okay. Now this pre-test call and the post-test call doesn't have the correct data type, so we are going to change the data type from object to float. All right, so let's do that now. So we are going to say df. Now we are going to slice that particular row, or we are going to call that particular row. So we say pre-test call. Let me just copy it here. So let me just paste it, df and pre-test call. So let me run it. You see, it's showing me that particular, it's just showing me that particular column. So when you do this now, you are slicing it, like you are telling pandas to show me only this column. So if I give space now, if I give space now and I do something like this and I copy age, it's going to show me only the pre-test call and the ages. Let me copy that now and paste it here, and ages. So let me run it again. Sorry, this got an error. Okay, let me remove this. Let's continue first. Let's get this. Okay, let's continue. Now this is the column I want to work on. So let me say equal to, I'm going to update. What I'm going to do is that I'm going to update this column, and I'm going to say df dot to numeric. So now what it's doing is that this particular column was actually an object. I want to convert it from object to numeric. So I'm saying df dot to underscore numeric, and I'm going to say now this particular code. Sorry, let me remove this. This is the reason why I don't like Google Colab. It's always autofill and I don't like it. Alright, so now it's going to this df dot to numeric, open bracket and close bracket, is actually what converts a data type from object to float, to numbers or floats. So when I say dot numeric, I'm going to tell pandas the particular row I'm converting. So I'm going to still say df this and pre-test call. Okay, pre-test score. Right, so this line of code is going to convert this particular row, this particular column from float, from object to numbers. So the df dot to numeric is the function that is actually converting this column to numbers, and once it's done converting, it's now going to update the same column with the new numbers that he has actually converted from. So let me just do this and let me run it. Okay, where is the error message? Now there's something we do here. We are going to add the coerce function because there's something going on here that we need to correct. Now it's trying to tell us that data frame object has no attributes to numeric. Now there's a particular cell here that has a number, or that has a symbol that is affecting this line of code. As such, we are going to use the coerce function to convert it completely. We are going to use the coerce function. So let me try to update this code. Let me give a comma here and say errors equal to coerce. So it's trying to coerce the error for me. COERCE. Alright, so let me run this again. Okay, let me run this again. Alright, this should work now. So let me call my df again. And let me say df dots. Now this is the pretest score we just worked on. Let me say df.info. Let me say df.info now. So let me check the data type whether it has actually changed or not. Let me scroll down. Now the pretest call has changed from object to float, and we are going to do the same thing with the posttext call, right? So let's go up again. Then let's copy this line of code and let's paste it here. Now let's change this to post. Let's change this to post, and let's change this to post as well, and let's run it again. Okay, I made a mistake here. Let me add the T and let me run it again. Alright, so let's check. Now you now discover that the posttext score and the pretest score has been converted to floats. Alright, so let's continue. Now there's also a problem here, and the problem here is that okay, let me check. This is an object, this is an object. Let me check again. The age is float, that's okay. The sex is object, that's okay. The location is object, okay. So everything here seems okay, so we can actually continue now. So let's continue. What do we do? What next do we do once we are done converting? The next thing we are going to do is that we are going to handle symbols. Let me show you something here again in the code. Let's say df.head again to still get a visual, or to inspect our data set again. Let me call out only one. There are symbols. Let me call 2. Let me just call 5. Okay, now there's a particular column that has symbols. Look at this. This question mark is a symbol. It's not a string, is not a float, is not a number. So how do we handle this? We are going to use the replace method. So the replace method is actually going to we are going to replace this with something else. So let me just record this code here now. I'm going to say df. Let me update our data frame. df.replace. I'm going to say replace everything that looks like this. Everything that looks like this. Now let me look for the question mark. Okay, this is the question mark. I'm going to replace everything that looks like this, and I'm going to replace it with a null value. So you can replace it with anything, but I just want to replace it in a null value. And let me run this line of code, and I actually done the replacement for me. Alright, so we can continue. Let me do the df again, check our code, and you see that the question mark is no longer there again. So we've replaced it. So we can use this to if there were different symbols, you can always use this df.replace to replace those different symbols. So let's continue. Let's do another thing again. There are still other errors in this data set. Let's look at them. There are still other errors. Now let's try to drop values where all the rows has null values, because that kind of row is not needed. Imagine this row 1, all of them has null values from beginning to the end. That kind of thing is not needed. That novel that kind of row is not needed at all. So imagine it was 10,000 rows. Let's just do it automatically. Let me say df equal to df dot drop any. So I'm telling you, drop everything. And how? I can just say drop everything and it will drop, but I want it to specify that it should drop everything, all the rows. Let me just say df drop all the rows that has everything, that all the values are null. So let me just run it now. Okay, that would drop. But at this moment, these are all our data set. No row has every information or every value null. At least this one has at least just one null. Just have 1 2 3 4 5 6 null values, but one has a value. So this passed the test. So with this now, nothing was actually changed. So let's continue, but you can always run this code to drop such kind of row. So let's continue. Now another thing we have to do is, let's replace numerical values with the mean of those columns. Remember we said we can replace values, you can drop them, you can replace them with the mean. Remember, if it's a numerical column, you replace them with the mean or with the standard deviation. But if it's a categorical column, you replace them with the mode. Numerical columns, you can do calculations on them, but categorical columns, you may likely not be able to do calculations on them. So you actually look for the most occurring values and replace it with that. So let's start with the column that has that are numerical. And how many numerical columns we have that we may likely do the replacement is the pretest call and the protest call, with the age as well. So let's start with that. So let's start with the pretest call. So we say pretest call. So let's just call it something else. Let me just do this now. Let me just say pretest underscore mean, because we are calculating for the mean value. So df is telling me it's completing the code for me, but I will still write it myself. Sorry. Pretest call dot mean. So this first code here calculates the mean of the whole column for me and puts it inside this variable. So let me run this line of code. That should work. Okay, let's continue. Now I want to replace it. Now I'm going to say df pretest call. So let's continue. Df, okay, I didn't add this. Let me just remove this now. Pretest call. Okay, sorry, hold on, any mistake. Okay, I'm not done with the code. Pretest call equal to df. As I'm updating this particular code, this particular column, let me just write the pretest call again. Sorry. Now, okay, let me write this pretest call. Now I'm going to fill it. Let me just take this. Give me a second. So I'm going to fill it with the mean that has already been inside this variable. So I'm going to use the fill any. So I'm telling me fill all null values with the pretest underscore mean. I can say fill all the null values with 0, fill all the null values with 1. So this line of code, this fill NA, is saying every null value in this particular column, fill it with something. So I'm for here now, I can say fill it with 0, and it fills all null values inside this column with 0. Or if I say fill it with the pretext mean, so the value that is inside this pretext mean that's already been calculated here is going to be filled in all the null values in this column. So let me run the line of code, and this will actually work. And let me say df now. Let me run this line of code again. Right, you see now our pretest score, all the values, all of them HANA has the value. Now the particular row, this row 2 that didn't have anything earlier, has now been filled with the mean of this column. So let's do that as well with the post test call. Let me just copy this line of code. Okay, let me copy this line of code. Okay, there's one here, so let me just paste it, and I'm going to change it to protest call. I'm do that with the protest call as well. So let me just quickly do some editing. Okay, so let me just run it now. I'm doing editing. Alright, so let me just scroll down. Where is this? Let me scroll down, and all the null values here has been filled with the mean of that particular column. So, and the last one is the age. What do we do with the age? We are still going to do the same thing as well. We are going to still fill it with the mean of that particular column. So let me do this. Let me just edit it with the age one. Just give me a second. Let me do that as well. Okay, let me just run this now. It's just to fill it, and all the ages now has informations. Now the next thing we are going to do is we are going to handle categorical values, like this kind of value. Now the first name and the last name, let's look at. Now the first name has no values, the last name has no values. Let's look at the mode. That's the most common value, and we are going to fill it in to those empty spaces. So let's use the same fill NA, but we are going to change it to the mode, right? So it's the same process that we just did. So let me just quickly do that again. Let me fill it, but I'm not going to use mean, because mean is actually a statistical calculation that involves a numerical column, but mode is a statistical calculation that involves a categorical column. So let me change it to mode, and let me change the name and the values. Let me change it to, let's start with the sex. SEX. Okay, let me add this. Let me say sex mode. Hold on. Sex mode. Let me change this as well. Sex mode. Alright, so we are done with this now. So let me just run this line of code, and that's it. That's filled the sex with the mode, right? So there is no null value here again. So let's run that. Let's do the same thing with the first name and the last name. So let's do that as well with the first name. So I'm going to just change this the sex to first name. Okay, so let me just run it, and this works as well. So everything here has been changed. So let's do the same thing to last name. Okay, let me just change all the first name to last. Let me quickly do that here. Last. Let me change this to L. Let me change this to last as well. That's as well. Let me change this to L. Alright, so let's run this. Wow, so we'll be able to clean the first, second, third, fourth, fifth, sixth, and the first 6 rows. The last one is the location. What should we do regarding this location on now? Because now we will not be able to do anything on this column because of how this NaN is written, right? So if we are saying let's drop null, it's not going to drop. So let's try to do that first. Okay, let's do something. Let's try to do whether it will work. If it doesn't, we have to convert it again. So let's drop all null values here, or let's just fill it with unknown. What do you think? Let's fill it with unknown because we don't know the location. Instead of it being null, let's just fill it with unknown. So just a df location, let's say equal to df location. Let me just fill it dot fill fill null. So let's just fill everything that is null value. Let's just fill it with unknown. So let's run it. df now all of them has been converted to unknown, right? So with this we have been able to, seems there is no null value here again, but if it was like 5,002,000 rows we are working on, we won't be able to see everything. So let's run this code to know, or to be sure that we've cleaned all our datasets clearly. So I'm going to say, let's check now whether there are still any remaining missing values. So let's use this code, print df, that's our data, that's our data frame dot is null. It's just giving me what to type, but I will ignore it. And let's calculate, let's sum it, or let's not use this print, let's just make it simpler. df dot is null. Let me do this first. We did this earlier, but let me just say dot sum, so it sums for each of the columns for me. Now wow, tells me all my columns, none of my columns has an empty has any null values again. None of them has any null values. But let me check something again before I complete. Yeah, look at this. Okay, this is okay, but let me just do something in case some of these columns actually changed. Let me just run this line of code again. Let me do some resets. So let me just say df equal to df dot reset. Let me try to reset the index, that's the rows, the row numbers. Just the index and drop. Let me make it true. Let me make the drop true. TROUE, sorry. Alright, so let me run it. So this works. Let me say df now. Alright, so with this we have been able to clean our entire data set. That's amazing. It takes a very long time to do a data cleaning. There are some that are much complex, there are some that are much more easier, but this was a very simple but complex data set, right? So if you see any of these challenges in your data set, either you are fill the NA, or if that's the null value, you are filling it with the mean, the median, or fill it with a number. Sometimes you are going to replace symbols with a particular thing, you are going to replace null value with unknown and the rest. So look at this video, check the strategies that we are used, and see the one that will actually work for you when you are doing your data cleaning. But first, and ways to assess your data quality at the end of the day is that you always check whether your data sets are complete, whether the values are in the acceptable range, whether it's actually consistent. That's it. And when you are done cleaning, that's when you do your pre-processing, then your exploratory analysis, then you start doing visualizations. But this is the first step in your data analysis project. Alright, so a project, or the first project, will be attached to this video. So you will go through this video and do the project to submit it at least before Sunday. Thank you so much.